Hello students, I hope from yesterday's video you have collected some information about polygons. Example, what is polygon, different types of polygon, and how to find the sum of angles of polygon, number of diagonals, etc. Right? Yes, using that information we start exercise 3.1. Exercise 3.1, question number 1 given here, some figures. Yeah, we have to classify them, which are simple curve, simple closed curve, polygon, convex polygon, or no concave polygon. Yeah, look at the first figure and second, they are bounded by line segment. Fifth figure and sixth figure are bounded by curves. Yeah, third, fourth, and eighth figures are combination of two figures. Means it is not a single figure. It have some parts. Yes. Yeah, look at the fourth figure. It is having 6 parts totally. Yeah. Eighth one, it is having 2 parts. That is, or else we can say two circles are joined by a line. Yeah. Now, simple curve means only it should be a single figure. It not have any parts. So they are 1, 2, 5, 6, and 7. Right? Yeah, it is not having any parts. It is single figure bounded by line segment or curve. But it should be a single. Yeah, first, second, fifth, sixth, and seventh. They are simple curve as well as they are closed curve also. So we can write under simple closed curve. Next, polygon. Yeah, as we know that polygons are bounded by only line segment. Yeah. First figure is a closed figure and it is bounded by line segment, and second figure also bounded by 4 line segments. Third one is not a line segments. No, it is not bounded by a line segments. Fourth one, we are having line segments, but they are intersecting. Line segments are crossing each other, so it is not a polygon. Understand? See, each line segments are intersecting each other at the middle. Yeah, polygon in the sense you should not cross each other. Their line segments end points only should meet. So first one and second one, the two only polygons, remaining all not polygons. Fifth, sixth, seventh and all, they are bounded by curves, so it is also not polygon. Yeah, next D sub question, convex polygon. See, second figure is a convex polygon in that each angle measure is less than 180 degree. Yeah. So convex polygon is figure 2. Next, concave polygon. That is figure 1. See, one of the angle measure is greater than 180 degree. Yeah. Which angle vertex is invert the figure? See in the figure. Yeah, that angle portion is invert inside the figure. Angle vertex is inside the figure. It means that angle measure is more than 180 degree. Yes, copy down this. No need of drawing the figures. Yeah, next second question. How many diagonals does each of the following have? How many diagonals? According to definition of diagonals, if we join non-adjacent vertex, that means opposite vertex, we'll get a diagonal. See, it is one convex quadrilateral. Yeah, each angle is less than 180 degree, right? If we join opposite vertex A and C, we'll get a line segment, no, AC. It is one diagonal. And if we join D and B, we'll get another one line segment, that is second diagonal, that is DB and AC are two diagonals of convex quadrilateral. Next, a regular hexagon. How many sides are there in a hexagon? Totally 6 sides. And it is mentioned specially. What is that? A regular hexagon means in a hexagon all 6 sides are equal. Yeah, we'll see how many diagonals are there in a regular hexagon. We should name all the vertex of the hexagon. Yeah, totally how many vertex it is? Having 6 vertex and 6 line segments, 6 angles. Now we'll see how many diagonals. Yeah, diagonals always should join opposite vertex. A opposite is C, A opposite D. From A only we can draw 3 diagonals. Got it? From A we are having now 3 diagonals, AC, AD and AE. Next, from B, how many possible? BD, BE and BF. Yeah. Now, totally we are having 6. Next, another one vertex from C. Yeah, from C already we drawn one CA. One more we will draw CE, CF. Yeah, 8 diagonals. From D, anything possible to draw? Yeah, 2F already drawn to A. So from D we'll draw for F, DF. Totally 9 diagonals for a hexagon. Which are the diagonals? We should name them. AC from A. Which are the diagonals? AC, AD, AE. Yeah, from B, BF, BD, BE. From C, CF, CE and CA. From D, DF, DA. Already AD we have written, no? Yeah, totally 9 diagonals for hexagon. Next, third figure, triangle. Yeah. Is there any possible diagonals can we draw? No. A opposite there is no vertex. B opposite there is no vertex. Therefore, triangle has no diagonal. Understand how to draw the diagonal? Yeah. Yes, copy down this. All the sub question you should draw the figure and write. Next, third question. What is the sum of the measure of the angles of a convex quadrilateral? Yeah, we know that sum of the angles of convex quadrilateral is 360 degree. Will this property hold if the quadrilateral is not convex? Nothing but concave. Not convex, nothing but concave quadrilateral. Yes, it is holds good for concave quadrilateral also. How? Let's prove now. Before that, we'll prove convex quadrilateral how it will be 360. Yeah, it is on convex quadrilateral. If we draw one diagonal, we will get two triangles. So we know that sum of all angles of triangle each is 180 degree. So 180 degree plus 180 degree gives 360 degree. So sum of all angles of convex quadrilateral is 180 degree. Now we'll verify with concave quadrilateral. Yeah, concave quadrilateral, one of the angle vertex should be invert. Right, like this should be. Now, if we draw one diagonal, if we join the opposite vertex, that is, first name the quadrilateral, join opposite vertex, AC. We'll get two triangle, no? Hey, again, we should apply angle sum property of triangle. That is, sum of three angle is 180 degree. 180 degree plus 180 degree, here also gives 360. Yeah. It is not a matter of convex or concave quadrilateral. It is generally a quadrilateral. The sum of all four angles of quadrilateral is always 360 degree. Next main question. What can you about the angle sum of a convex polygon with number of sides? See, now we are going to find sum of all angles of convex polygon. Yeah, this is the formula n minus 2 into 180 degree. Yeah, we know that sum of angles of triangle is 180 degree. Sum of angles of Quadrilateral is 360 degree. What about 5-sided polygon, 6-sided polygon and 10-sided polygon? Yeah, to find their sum of angles, we should use this formula. What is that formula? Sum of all angles of a convex polygon or concave polygon is, this is the formula, n minus 2 into 180 degree. Very simple it is. In that, n is what? What is n? N means number of sides of polygon. Yeah, here given 4 sides, that is first 7 side, second question 8 side, third question 10 side, D question n sides. Yeah, let's see how to find the sum of angles of a polygons. Yeah, A question, n equal to 7. Sum of all angles of a polygon, 7 minus 2 into 180 degree. N place we should substitute 7. It gives 5 into 180 degree. Yeah, if we multiple, what will get? 900 is the angle sum of heptagon. Septagon or heptagon. 7-sided polygon name as septagon or heptagon. Next. Yeah, B, you do as homework. I'll do C now. How many sides? C polygon have 10 sides. That is n equal to 10. Each question should write the formula. Sum of all angles of polygon is equal to 10 minus 2 into 180 degree. Because n is here 10. 10 minus 2, 8. First we should simplify inside the bracket, no? So 10 minus 2 is 8 into 180 degree. If we multiply, we will get 1440 degree. D, here n equal to n only. Yeah. So n place what we should substitute? N only. So sum of all angles of a polygon, we will get the same formula itself. N minus 2 into 180 degree. Got it? Yes, copied on all these answers. Last one, that is n minus 2 into 180 degree. It is not visible. So same formula itself. Okay. What is a regular polygon? State the name of regular polygon of. Yeah, we know that regular polygon has sides of equal length and equal angles. Right. Now we should name 3 sides having regular polygon. Which is that? 3 sides having regular polygon. 3 sides triangle only have 3 sides. So in that all sides are equal. Which triangle it is? Good. Equilateral triangle. Yeah, similarly tell for 4 sides. In quadrilateral, which, yeah, it is square. 6 sides, that is hexagon. We are not having special name. So it is regular hexagon. So equilateral triangle, square and regular hexagon. Given these 3 are regular polygons because they are having equal sides and equal angles. Yes, copy down this. Further details about polygon, I added a video. Watch it. Thank you.
Welcome to the lesson on polygons. At the end of this lesson, you will be able to classify polygons based on the number of sides or vertices. Differentiate between convex and concave polygons, and between regular and irregular polygons. You will also be able to calculate the sum of the interior and exterior angles of a polygon. John and Alice, can you observe the patterns on the floor? These patterns are made of polygons.
Polygons?
What are they?
A polygon is a simple closed figure made up of only line segments. Some polygons you already know are a triangle and a square. You can see that the floor designs are made up of quadrilaterals and octagons.
What is an octagon?
The octagon belongs to the family of polygons. It is a simple closed figure made up of 8 line segments. Come, let's learn more about polygons. First, we will learn how to classify polygons. So, how many varieties of polygons can we think of? Many. Can we say? Yes. Let's see how we can visualize different polygons. Let's start with a simple polygon, a triangle. A triangle has 3 sides and thus is a 3-sided polygon. If we cut the triangle at one vertex and add a side, it will become a 4-sided polygon, which is called a quadrilateral. Again, if we cut the quadrilateral at one vertex and add another side, it is a polygon of 5 sides, which is generally called a pentagon. In this manner, we can obtain a 6-sided polygon, a hexagon, a 7-sided polygon called a heptagon, and so on. If we have an n-sided polygon, it is called an n-gon. Take a look at the table to understand the classification of polygons according to the number of sides or vertices. Let us now learn what a diagonal of a polygon means. We know that each side of a polygon is connected by 2 consecutive vertices of the polygon. Now, we take 2 non-consecutive sides of a polygon and try to connect them. Let us consider vertex P. The consecutive vertices are Q and T. The rest of the vertices R and S are non-consecutive vertices. We connect the vertices P, R and P, S. These line segments are called diagonals. Therefore, we can conclude that a diagonal is a line segment that connects the non-consecutive vertices of a polygon. Alice and John, can you show the other diagonals of this polygon?
From vertex T to vertex Q and vertex R.
From vertex Q to vertex S and then to vertex T.
The diagonal from T and Q is already drawn. So, it is considered as a diagonal from Q to T. So we can conclude that a line drawn connecting 2 non-consecutive vertices of a polygon is called a diagonal. So, a diagonal in a polygon is drawn connecting 2 non-consecutive vertices. Now, let's look at this figure. It is a polygon in all respects. John, can you draw the diagonals for this polygon?
Here they are. But how to draw a diagonal between these non-consecutive vertices S and P?
It seems that the diagonal drawn between these points lie outside the figure. That's a good observation, John.
If a diagonal lies outside a polygon, then the polygon is called a concave polygon.
If all the diagonals lie inside the polygon, then the polygon is said to be a convex polygon.
Can we see some examples of convex and concave polygons?
Oh yes, definitely. Look at this polygon. How can we verify if this polygon is convex or concave? Let's start by drawing diagonals from vertex A to the non-consecutive vertices C, D, E, F and G. Similarly, we draw diagonals from vertex B to other non-consecutive vertices. Now, we draw diagonals from vertex E to other non-consecutive vertices G and H. Likewise, we draw diagonals from vertex F to other non-consecutive vertices. Now, observe that diagonals EG and FD lie outside the polygon. Therefore, this is a concave polygon. Now we will see 4 polygons. John and Alice, here are 4 polygons. Name them and identify if they are concave or convex polygons. Alice, you first.
The first polygon has 5 sides. So, this is a pentagon. Now, on drawing the diagonals, we see that all lie inside the polygon. Thus, it is a convex polygon.
Now, it's your turn, John.
This polygon has 5 sides. So, this is a pentagon. To check whether this polygon is convex or concave, I will draw the diagonals. One diagonal lies outside the polygon, so this is a concave polygon.
The next polygon has 6 sides. So, this is a hexagon. Since 2 diagonals of this polygon are lying outside the figure, this hexagon is a concave polygon.
The fourth polygon is an octagon since it has 8 sides. All the diagonals lie inside the polygon. Therefore, this is a convex polygon.
Thus, 2 polygons are classified as convex and the other 2 as concave based on the position of their diagonals. Now let's differentiate between 2 polygons that have the same number of sides, based on the length of the sides and the measure of its angles. We have 2 polygons here. Alice, can you tell the difference between the polygons?
The number of sides is the same for both the polygons. However, it seems that the first polygon is quite different from the second.
How are they different, Alice?
Look at this polygon. Each side of the polygon is of the same length. Also, the measure of each angle is equal. On the other hand, in the first polygon, the lengths of the sides and the measure of the angles vary from each other.
Oh yes! Then how can we name these 2 polygons?
That's a good question, John. The polygon with equal sides and equal angles is called a regular polygon. The polygon with unequal sides and unequal angles is called an irregular polygon. To conclude, a regular polygon is equiangular and equilateral. If a polygon satisfies these 2 conditions, then it is said to be a regular polygon.
How do the words equiangular and equilateral connect to a regular polygon?
Okay. The word equiangular means the interior angles of the polygon are equal to one another. The word equilateral means the lengths of the sides are equal to one another. If a polygon needs to be called a regular polygon, then it should satisfy these 2 conditions. For example, take a rectangle. Here, the interior angles are equiangular, but the sides are not equal to each other. Therefore, it is an irregular polygon, whereas a square with all sides and angles equal is a regular polygon. Now we will learn about the sum of the interior angles of a polygon. When we say interior of a polygon, we are talking about the region that is bounded by its sides. Each interior angle of a polygon is the angle made by two consecutive sides. Here, we will find the sum of all interior angles of a polygon. This is called the angle sum. To start with, we will find the sum of the interior angle of a triangle. Alice, can you tell us the sum?
Yes, it's 180 degrees.
Good, Alice. Now, John, look at this square. Can you tell us the sum of the interior angles of this square?
It's 360 degrees.
Good. Now, if we consider a polygon like a heptagon, finding the sum of the interior angles needs a formula. The angle sum of a polygon is given by n minus 2 multiplied by 180 degrees, where n stands for the number of sides of the polygon. Let's verify the formula for the triangle. It consists of 3 sides. Therefore, n is equal to 3. Therefore, the angle sum of a triangle is equal to 180 degrees. If we consider the heptagon, the angle sum is 900 degrees. So far, we have discussed interior angles.